Hi everyone. Today we want to learn the application of a soil salinity monitoring with the MODIS data in a Google Earth engine. Soil salinity is a critical environment factor that influences the agricultural productivity, ecosystem health, and the water management, and it affects crop yields, reduce the soil fertility, and can lead to desertification if not managed effectively. Monitoring soil salinity over large areas, especially in arid and semi-arid regions, is essential for sustainable agricultural practices and land management. Remote sensing provides an effective means to monitor soil salinity at a global scale. And in this tutorial, we use the MODIS Surface Reflectance data to create the Soil Salinity Index, or which is a proxy for the soil salinity. And this index is derived by calculating the normalized difference between the short-wave infrared or SWIR band and near-infrared or NIR bands, where higher values are indicative of a higher soil salinity. Additionally, we generate a true color composite to visualize the study area more naturally. So if we going to the code.elfng, we need to define the area of interest. We start by defining the area of interest, or AOI, as a rectangular region over the Indus Basin in Pakistan, using the geographic coordinates, and this allows us to focus the analysis on a specific region of interest. If you don't know how to calculate this bounding box, you can watch the video related to this. And after this, we need to define the start date and end date. We selected the January 1st, 2024 to 31 of December 2024. This helped filter the MODIS data set for the desired time frame. And after this, we need to load the MODIS surface reflectance data. We load the MODIS mod 09A1 surface reflectance data, which provides the reflectance value for various bonds like the SWIR, near infrared, red. And this data is filtered by the area of interest and date range, and then we apply scaling factor to adjust the reflectance values. You can search this in Google and find the related description, dataset description in Earth Engine data catalog, dataset availability, temporal isolation, and you can find the bond name, min-max, scale, wavelength, and the descriptions. And you can, yes, if you want to explore more, you can read the user guide after this. And after this step, we need to compute the median composite. We define the var median, and we create the median composite of a MODIS image over the specific period to reduce noise and represent the average reflectance value for the time frame. And after this, we need to calculate the soil salinity proxy, and or SI1 index is calculated by applying the normalized difference between SWIR bond 6 and near infrared bond 2. And this index helps in detecting the areas with higher salinity, and where positive values indicate the higher salinity levels. And after this, we need to create the True Color Composite, because we want to compare the salinity index with the True Color. Is generated using the red bond 1, green bond 4, and blue bond 3. And this provides a visually realistic representation of the landscape. And the next steps is a surface. Set a visualization parameters. We define the visualization parameters for both the soil salinity index and True Color Composite. Adjust the color palettes and contrast. The SI1 visualization uses range from -1 to 1, with the color palette representing green low salinity, yellow moderate salinity, and red high salinity. And the True Color Composite is visualized with the contrast range 0 to 0.3. And the final step is adding on a map. We add both the Soil Salinity Index and True Color Composite layer to the map for visualization, and this allows us to see the distribution of a soil salinity as well as the natural color of the landscape. If we run this code, zoom it on the case studies areas and loading the Sentinel-2 to MODIS to color image and soil salinity, you can see the vegetation areas has a green color and the soil areas has a red color showing the higher soil variable. So what's application of this? In agriculture, soil salinity is a major factor influencing the crop growth and agriculture yields. Monitoring the salinity helps in identifying the areas where crop might suffer and implementing better soil management practices. In the land restoration, in arid and semi-arid region, soil salinity can lead to land degradation. Identifying the salinity hotspot helps in planning, land reclamation, and restoration efforts. In water resource management, in region with high evaporation rates, salt accumulation in the soil can result from poor water management. Remote sensing can help track changes in the soil salinity over time. And in environmental monitoring, soil salinity is crucial for understanding the ecosystem health, especially in a wetland and coastal region. And it's also helped track the impact of climate change and human activities on soil and vegetation. Yeah, if you're interested in soil salinity, you can watch the video mm, from the Sentinel-2 and Landsat. We created the Soil Salinity Index from these satellites. Thank you for your watching. Please like and subscribe to our channels.